Welcome everybody to the last session. Thanks for being here. I'm looking forward to getting outside because it looks like an amazing day. So I'm Kyle Haley. If you have questions, feel free. You can email me at kyle@buildix.com. A lot of the content of this presentation is on my blog at kylehaley.com. I'll put the slides up next week probably on slideshare.net. There's a previous version of these slides already if you want to go back and look at the old version. So the question on the DBA I get anxious about all the time is what happens when somebody says the database is running slow and all the pressure's on me and I'm supposed to figure it out. What's the first step? What do I do? What are the questions I ask? What are the tools I use? And do I have a repeatable method or do I just sort of wing it? Well, there's a tool that we all know and love, I guess. Anybody know what this is? AWR report. Anybody know what's going wrong in the database? It's slow, you got it. What if your dashboard of your car looked like this? What if it was only updated once an hour on your dashboard? Would you rather look like that, or would you rather look like this? So that's really cool. This is top activity from Enterprise Manager. So for me, I think it's super easy. The thing on top is the load on the database. Is it high or low? What do we compare it to? Well, we compare it to the number of CPUs on the machine. If our load goes way above the CPUs, we've got a bottleneck. Maybe acceptable, maybe not. If we're a data warehouse and we want to run as many parallel query threads as we want, we might have a lot of I/O that might be acceptable. Otherwise, though, if there's a big spike, it's probably a bottleneck. Where is it coming from? It's broken down at the bottom pretty easily. We have a top SQL, top session. So I can find out where is that load coming from and analyze it. For example, I can see this right away. If I wanted to, so in the spike on the right, the green goes above the number of CPU. How is that possible? The reason that's possible is because there's more of a demand for CPU than there's a CPU on the machine, which means we have a CPU bottleneck. Well, how do I get CPU back? Where do I go? Assuming I can't just add more CPUs to the machine, which a lot of people like to do. If I want to choose a system, I go to the top SQL. There's one SQL using up almost all the CPU, that first SQL. If I want to get the biggest bang for the buck, that's where I'm going to put my energy. So now I have a cool interface, easy to read, and a methodology. But we don't always have OEM. So where's OEM getting this data from? And this is where it comes from. It's based on the wait events, which we use a process called sampling to capture them. That becomes active session history. We display it in Enterprise Manager in top activity in a value called AAS, or average active sessions, which is the load on the database. So let's go through this. What are weights? So how do we get the weights? Well, we don't always have OEM. We don't always have AWR. It depends on the database you're on, but we always have Statspack. And Statspack is pretty much equivalent to AWR. If you run a Statspack report, you get all these different sections, a bit overwhelming as we saw, but there's one section called top time events. That's where the wait events are. And here's the Statspack method from my point of view. This top column here is a Statspack report, or AWR report. It's pretty much the same. Where do I go? I go to the top, that little red square. You can see the top. Zoom in. That's the header. We have what database this was and when was it happening. We have a summary of statistics. Here, this stuff's sort of cool. This is load profile of the database, like how much read are we doing, how much reading are we doing, how many transactions, commits. This jump below it is all the ratios. You can just throw that stuff out and forget about it. And below that, we have what I think is the coolest part. These are the weights. This is the first thing I look at. What's happening in the database? Where is it spending its time? I love this quote from Kellen Podvon. She said, if you're not tuning for time, you're wasting time. Well, this is where the time is found. So you zoom into this, and then we have where our time is being spent. First thing I see is this first line says bucket busy waits. I'm waiting for some resource, I can't get it. What kind of impact is that having on the database? If I look at the last column, 78% of the time of the sessions in the database are spent on this wait event. That's a bottleneck. We're not getting work done, we're waiting for something. So let's look at a few of these wait event sections. So here's one case, the top thing is that, again, there's a problem. Ideally, what I want to be doing is using CPU. On the CPU, I'm doing work. I'm accomplishing something in theory. But if I'm on a wait event, then I'm waiting to do work. I'm blocked. So So in this case, there's a latch tree I'm waiting for. But how do I solve it? There's hundreds of latches. Which latch am I waiting for? Now, Oracle has made improvements. A lot of latches get their own wait event name, but there's still a latch-free bucket for the other latches, and it's still happening. Now, I can go look in a Statspack report, and I can find out which latches we're sleeping on. In this case, the most important latch I'm spending time on is the first one, cache buffer chains. I look at that column sleeps. The one I'm sleeping on the most is the one that has the most problem. But what do I do? Where do I go from now? I need to know who's involved. I need to know what SQL. But I don't have any of that information in Statspack or AWR. This is a simple thing, which should be simple. Transaction log. Two sessions are continuing over the same row. They want to modify. That's simple. It's just a simple lock. The problem is, what do you do? I can see there's a problem. 41% of the database time spent waiting for this lock. What do I do about it? I need to know who's waiting, who's blocking, what SQL, what row. It's not in Statspack. It's not in AWR. But busy wait's the first one we saw. Okay, well, how do I solve it? I need to know who blocks, what object, what SQL. It's not in Statspack. Statspack's basically a failure. So what do? We do something called sampling. So what is sampling? So we see in Statspack that if I have this information, I don't have enough to go on. So I want another way to get the information. In the case there's a buffer busy wait. Well, how do I get information for the buffer busy wait? What I need to know is what SQL has buffer busy wait, what sessions are involved, what objects. I need to get that information, but it's not in AWR Statspack, but it is in a view called $session. And $session will show us who's waiting. But the data only exists while the problem is happening. Once the problem's gone, the data's gone. And it'll give us all the information we want. It'll tell us what SQL is having the wait, what session, what object, the type of buffer busy wait, which we'll see how to use, and even the file and block involved. But once the problem's over, the data's gone. So what if I want to go back and see what if somebody says, oh yeah, Kyle, yesterday at 5, something wrong on your database, it was running slow. What do? Well, I can't look at $session anymore, it's all gone. So what do? Is we capture it. We do it by a way called sampling. We get that data out of $session and save it somewhere. So this query actually ran from version 7. We could have done this back in 7. And it still runs through version 12. And it's going to tell us, first line is the user, their SID and serial number, which is like their unique connection identifier, what SQL they were running, what they were doing. Were they waiting on the CPU? And if they were waiting, what wait event were they waiting for? And we have these P1, P2, and P3, which are detailed information about the wait event. We run this in a loop, and we save it in a table. So I can do something like this. If I run the query by hand, the output looks like this. So I have some sessions, their SID and serial number, what the SQL hash identifies the query they're running, what they're spending their time on, and P1, 2, and 3. Now, if I run that every second and I save it to a table, then I'll have a history that I can go back and analyze and find out the information I require to solve the problem. So I say create table $ash as select, and then I run insert into $ash, that select statement that we just saw, and I run it every second. Now, if we have the buffer busy wait, what can we do? Well, for buffer busy waits, you can go into a view called $bitname, which will tell you what these P1, P2, P3 values mean, or you can look it up in the documentation. So for buffer busy wait, P1 is a file that we're waiting on, P2 is a block, and P3 is a type of block. So if I go in, so I've got this new table that I've created called $ash that I've sampled into. And I want to say, well, what kind of block types are we waiting on? So I go select P3 from $ash, where I'm waiting for buffer busy waits. And I see that every single one of these buffer busy waits is waiting for a block type 1, P3 equals 1. Well, what is P3 equals 1? This is a little bit of a trick. And this is where ASH gets complicated, I think, and this is why I want something called an ASH repository, where we all put our SQL scripts that we've discovered on ASH together, so we don't have to find these things out when we're under pressure. But for buffer busy waits, to decode the block type, you can look it up in $waitstat. So I say select row number, common class, $waitstat. The row number will correspond to the ID I find in P3, and then you can see what it is. In the case, we saw all our buffer busy waits run 1. 1's a data block. Okay, next step, what else can I find out? Well, P1 and P2 are the final blocks. Let's go into $ash, look at the buffer busy waits, and see what P1 and P2 are. Well, the file number is always the same file, and see the block number is like increasing. Well, what object is this? So let's look up the object. I'll take a file number and a block number, and I'll look up whether in DBA extends, where the file number equals our 11, and our block numbers between block ID and block ID plus blocks. I discover my object that I'm waiting on is owned by system. The segment name is Toto1. It's the segment type table. So now I know that I'm waiting on a data block in the table Toto. Well, what query is causing the problem? Okay, well, let's go into ASH and say, give me the SQL hash value for all the buffer busy waits. And every single one of them is waiting for the exact same SQL hash value, 5, 5, 8, whatever. We can look this up and find out what the text was. So I look under SQL text for the hash value, and I find my SQL statement. All the stuff that was missing from AWR. Inserted Toto values and some values. With this, if you know what a buffer busy wait is, this is enough to solve the problem. We know it's an insert statement, we know it's on a data block, and we know it's a table, and the table's named Toto. The problem, and I'll explain it in the graphic in the next slide, is that we either are missing free lists or we're not in ASSM, which is automatic segment space management. What happens when we don't have free lists? If we have multiple sessions inserting, they come into a table, they look at the header block, and there's a pointer to the free space. Well, all those sessions will go to the same block. And they'll all try to insert in the same block at the same time. Only one session can modify the block at any point in time, so the others have to wait. That's a buffer busy wait. How do we rectify that? We can add free lists, so that in the header we'll have multiple free lists, we'll hash on the process, and the inserts will be distributed around the table. There won't be a point of contention. If you happen to have a buffer busy wait on an index, it's a little different. What typically happens in the index is if I'm inserting orders, it's like order number 1, 2, 3, 4, it's monotonically increasing. The leading leaf node will be the hot block. That's where everybody's inserting the data. Two solutions to that. One would be doing hash partitions, so you distribute the inserts across the hashes. Another potential solution would be using reverse keys. So instead of inserting 101, 102, 103, we flip it. Insert 101, 201, 203. So then the inserts get spread out on all the different leaf blocks. There's no longer a block. So I didn't mean to go into buffer busy waits too much. I want to talk more about ASH. But we found the information we needed in ASH by sampling $V session every second and storing it in a table. Well, this is done automatically by Oracle. It's called ASH, or Active Session History, and it's in the view $V Active Session History. That's ASH. So what else is in ASH? There's a lot of stuff in ASH. ASH, these are going to go out through some of the fields of ASH. We have when we took the sample. We have what the session was. Now, there's a number of ways to identify the session. Session ID, serial number, user ID. We have what state were they in. What were they doing? Were they waiting or were they on CPU? And if they were waiting, what wait event were they waiting on? And give me details about that wait event. And then finally, I have a SQL statement. What SQL were they running? So that looks like a lot of fields, but we can break it down into the basics. The basics are, when did it occur? Who was it? What state were they in? And what SQL were they running? Now, for state has two options, values, waiting on CPU. But if they're waiting, we need to look at the event and find out what wait event they're waiting on. Ideally, I wish they just put CPU as another wait event. It would make querying a lot easier. And then as far as grouping, now we can look at ASH and group our analysis in a number of different ways. We can look for sessions. We have ways to identify sessions, users, services, module action if you tag the field SQL, client ID, use session pools, the program, the SQL. If you're using parallel query, the query session, query pointer. You can look at weighted group by wait events. You can group by objects, files, and blocks. Be careful with these last three fields. They're not for everything. Current objects, number, file number, block number only for I/O, blocks, and buffer busy waits. If you see the values for other wait events, they're going to be misleading. So we've got ASH. We've seen that it's a powerful repository for performance information and analysis. How do we start querying it? This is probably the key thing about ASH. All we do is, the main thing we need to do is select count star. Count star is going to be the number of seconds we waited for something. Statistical approximation. So select count star from ASH, where are our criteria? Where, for example, wait event equals buffer busy wait. And then we give it a time period. Where's the start and end time period? That's the basic core of an ASH query. Now, a simple change to the ASH query makes it more easier, more intuitive for me to understand the output. If we select the count star, the seconds by the time period, we have a value called AAS, or average active session. That's like the run queue on Unix. How many runnable processes are there? This is how many runnable Oracle sessions there are. And then we can specify our criteria. Are we looking for something specific, and what time period do we want to look at? This is a load on the database. Is a load high or low? Once we know AS, if we're looking at the database as a whole, we can say some things. If A is less than 1, the database isn't blocked. If AS is near 0, this is really cool. It means the database is idle. I don't know how many times the applications guys call you and say the database is slow, but you know it's not the database. Well, how do you prove it? Well, one way to prove it is go look at AS. If the load on the database is near 0, there's no load on the database. There's no weights in the database. The problem has to be in the application tier. If AS is less than the number of CPUs, you're probably not blocked, but a single session could be blocked. A single session could be spending 100% of its time waiting for something. But the database as a whole is not blocked. Once your AS goes above the number of CPUs, then you start running into bottlenecks. If AS is way bigger than the number of CPUs, you've got a bottleneck. These rules are the ideal world. This is imagining one database on a machine and no other major application on the machine. If you do have multiple databases or other applications on the machine, in order to use these rules, you need to track the CPU usage by the other applications on the machine. And whenever AS is greater than 1, there could always be a single session that's blocked. Okay, let's start running some queries on ASH. So imagine we have a large CPU consumption in our database, and we want to find who's causing it. What session's eating up our CPU? Well, pretty easy. I'm going to go in and say, select the session ID, count star from the active session history, where the sessions are on CPU, give my time range. In this case, it's the last 5 minutes. Sys_state minus 5 minutes. Group by the session. So who's eating up my CPU? Here's the output. I have 5 sessions here. The count star is by far the highest with session 257. This is 5 minutes, so how many seconds in 5 minutes? 300. This guy is basically at 100% CPU the whole time. Now that's pretty cool. I found that out pretty quickly with ASH. I like graphics, so I'm going to take the same query and just add a little graphic. Sorry, before I add the graphic, one thing. Count star doesn't speak to me. It's not very intuitive. What does 299 mean? I don't know. What it means is relative to the elapsed time. Elapsed time is 3 minutes. 299 over 300, almost 99%. The guy was 100%, close to 100% busy on CPU. That's what I want to know. Let's translate the output into something that's a little bit more intuitive. And the metric, the value I use is AS. So it's going to be count star divided by the elapsed time, average active sessions. If a single session is 1, that means it's 100% active. So same output, in this case it says AS is 99, so it's 99% active for that session. I like graphics, so you can like visually lead me to where I want to look. I basically just add a little bar. So the 10 is going to be the maximum characters wide, because AS per session goes 0 to 1. Run the same query, and I get a bar. I see immediately visually somebody's spending a lot of time on CPU. How about a user calls up and says, everything's been going good all day to the last 5 minutes. I don't know, right now my queries are sluggish. My subsequent queries are taking several seconds now. What's going on? Well, I could run a query like this and see which sessions are waiting. So I do the same thing I did for CPU, but now I look for waiters. So select session ID, count star from ASH, where sessions are waiting. What session is spending the most time waiting? And now it looks like this. Odds are that the session waiting was that first session, because he's the only one that's spending time waiting for things. So the last 2 queries we're talking about sessions. Well, I don't particularly spend my time looking at a single session. I typically look at SQL. What SQL is putting load on my database and how? So you can do the same thing with SQL. Instead of selecting session ID, I select SQL ID. And then I want to know what's the profile that's SQL. So I'm going to count CPU load, count waiting, and count IO. So that's the green, orange, and yellow. And then we have an output like so I didn't specify any time. So this ASH is in memory. It's a buffer. Oracle targets about 2 hours of buffer, but I mean it's completely variable. If your database is idle, it might have 24 hours of data. If your database is really busy, it might have an hour. Without a time window, it'll query the whole thing. So the output's like this. If I'm looking who's eating on my CPU and I need to save CPU, this first query is blowing everybody else away. It's the one that's eating all the CPU. Waiting is like no waiting time. There's a little bit of I/O wait time in the last column, and then we have the total count. So now we're looking at some queries on ASH. Last one we did was top SQL. What about top session? So we looked at the first two queries are session by CPU, session by waiting. How about putting it all together? So this is just like the SQL thing, top session. So who is the session, how much time on CPU, how much time waiting, how much time I/O, and what's the total? Output looks like this. So session ID and serial number, those are unique identifiers. I have the user ID, the program, and then the first guy is burning up a lot of CPU. A couple of problems with this though. I don't know if these guys are still connected. They could have disconnected. I'm like scanning the whole buffer in memory. They could have disconnected by the time I'm looking at the system. I also don't know who user ID 1 is. Could I translate that to the actual name? So I want to add some decode to make it a little bit more usable. So I'm going to join. So I have my previous query in the middle in red, and I'm going to join to get all the session to find out whether they're connected, and join the username to decode their username. But imagine this, that previous query is pretty big. This is the previous query. I'm going to stuff this in the middle of this pretty decent sized query. I'm getting a big query. But the outputs are nice. It tells me first column who's still connected, who's disconnected. What was the name? So CPU monitor was the guy burning all the CPU. What program is he running? Change manager. And then how much CPU is he using. That looks pretty cool, but the query is getting complicated. Kind of stuff that I don't want to sit there and type for the first time under pressure. So ASH queries can be complicated. We're going to go over the keys to ASH, the difficulties, pitfalls, and the solutions. So I mentioned some of this already. The key to querying ASH is to use count star. It's going to be a statistical approximation of the seconds spent doing things, whatever your search criteria are. Average active sessions is a count star divided by the elapsed time. And I combine CPU and wait event into the same column. Makes it easier. Decode session state is on CPU, say CPU, otherwise give me the wait event. Okay, difficulties. Well, as we've seen, the queries are complicated. One thing I find extremely annoying is the time window. I often want to specify start time and end time, but I constantly have to put that info into a query that's just time consuming. Pitfalls. Some of the fields, time waited is misleading. I wouldn't use it unless you really know what you're doing. Wait time is superfluous. Really what Oracle is using wait time is as a decode for what state we're in. If it's greater than 0, it means we're on CPU. If it's 0, it means we're waiting. But there's already a column that tells us that, so we just forget that field. I wish they didn't put it in there. If we go and look at historical active session history, it gets a little bit more complicated because DBA active session history, which by default has a week of ASH, it only has 1 in 10 samples, so it's going to change how we write the queries. In my opinion, the solutions have a pre-written repository of queries. So we're going to go through some of the queries in this repository called Ashmaster. And I encourage everybody to contribute. Some people have checked out, found things they wanted to improve. They made improvements, checked it back in. It's pretty cool. So it's a community collaborative thing. So 5 types of queries. We're going to look at load charts. We're going to look at queries that analyze specific wait events, like the buffer busy wait or the locks. We'll look at SQL elapsed times. We'll look at top queries, top session, top SQL, and finally I/O. One last thing I want to talk about, if we have time, is how to get latency. I don't get latency from ASH. It's very related to ASH, but I don't get it from ASH, and I'll show you what I use to get latency. But before we jump into Ashmasters, I want to point out ASH report. I've been on systems where I didn't have Enterprise Manager, and I didn't have any queries, and I wanted to access ASH data, and I'm like, under pressure, I'm like, I can't start writing these queries by hand. Well, there's something that's always available called ASH report. If you have the distribution Oracle Home, you can access shells to the file ASH report SQL, but you don't need it. You can just run it as a procedure. So select star from this function DBMS workload repository ASH report text. I get the DB ID of my database, my instance number, and the start and finish time. And it will run a set of 16 different queries on ASH. So I always have access to some queries on ASH already in the database. This is what the output looks like. This is pretty cool. I just marked a couple things in red. I see the number of CPUs is 2. The other thing I marked in red is average sessions per CPU, 6.19. This database has the bottleneck. I can see it immediately. Where's the bottleneck? If I go down and look at events, CPU plus wait, that's where I'm spending all my time. This has a CPU bottleneck. You can also output the report in HTML if you want, same information. The report has these 16 different areas. I sort of marked the ones in red that I find important. What we just looked at, top user events. You can also see top SQL, top sessions. And then we can see what's like a load chart. Load chart in Enterprise Manager is activity over time. I don't find it very friendly, but it's definitely nice to have it if I don't have access to anything else. This is activity over time, the last part of the ASH report. So for each bucket, it tells me what activity was going on in the database. Okay, Ashmasters. I'm going to talk about GitHub. How many people use GitHub here? So, fair number of people. GitHub is really cool. It's free. Okay, I don't know about you, but I'm always writing SQL statements, and sometimes I'm changing from machine to machine. I don't forget which machine I left the best version of my query on. Well, now I can have a centralized repository. I always put my queries in the GitHub, and I know that's going to have the latest version. And it's version controlled, so if I make a mistake, I can go back to an older version. And then we'll talk about these 5 types of ASH queries. So GitHub's really cool. Let me try it. See, I just bring it up on the browser. So if I just, this is a live browser, if I go to github.com/khaley, it shows me our repositories. The second one's Ashmaster, so I can just click on it. You've got, this is open to the public. Here's the different files. There's a README at the very beginning. What's in this thing? Click on a README and it'll talk about what's in here and what these scripts are and what they do. Then if you sign up to GitHub, you can actually duplicate this repository, modify it the way you want. You can ping me when you make changes. We can merge the changes. Okay, first section I want to talk about load charts. I think these are the coolest thing. So, if somebody gives me access to a database and says we had a problem sometime yesterday, I don't know when it was, but the users are complaining, you should look into it. Well, now I have 8 working hours, a potential area where there's a problem. How do I find out where the problem was? How do I know where to look? There's a lot of data in ASH. What I want, what I really want, is some way to scan across the data quickly and say this is where the performance problem was. How do we do that? I do that by creating a load chart. What's the load on the database over time? It's just like Enterprise Manager. And then I'm going to make some improvements to it. How do I've got a load chart, but what were the major wait events when there was load? I want to add that to the script. And then I want to modify the script to let it run over the repository. So this is what the output looks like. So there's a script on GitHub called ASH graph. And what is it? So we have this first column is time. This is by hour. Then I have average active session for each hour. And then I have a graph. Well, what is that graph? Let's take this and turn it on its side. Turn that over. Boom. That is supposed to be that. So if these are hour buckets, I can scan a whole day really quick and see where there were spikes. I can see there was a spike right in the middle. What are those pluses and minuses? Plus is average active session on CPU, and minus is on some weight. That 2 in the middle is the number of CPUs. So it's the same as the red line in Enterprise Manager. So now, the green would be CPU in Enterprise Manager, plus would be CPU in ASCII art in SQL. So, in the SQL version, I can see there's a spike, but what is a spike? What is the wait event that we're waiting on? So I modified it, so there's ASH graph weights, which adds in the weights. So this has the top 2 weights. So here's a spike, what's going on? The top weight was DB file sequential read, 1.25 AS, and the next one was log file sync, 0.5 AS. So now I found my problems, IO problem. Mainly read, a little bit of write. So those are the top 2 ways. So how do we do that? This might be a little tedious, but for those of you who want to jump into this stuff on GitHub, this might help you navigate around. But basically what we're doing is we want to create buckets, time buckets, every hour, and then average the weights and CPU in that bucket. So I need to create a bucket ID. This is pseudocode, this isn't real. I need to create a time, a bucket ID, how much CPU was in that bucket and how much weight was in that bucket. So the main thing here is how do we create an ID? We need to create a bucket ID. I'm going to take a number of days, number of seconds in the Julian date. So Julian date's number of days. So I multiply days by seconds in the day, and I add on the number of seconds in the day. And I divide it by my bucket size. And I truncate it. This will be a bucket ID. And then for each of these bucket IDs, I'm going to count CPU and weight. And that's the raw data that we're going to use to create these graphs. So here's what it looks like. I have my bucket ID, my count CPU, count weight, grouped by the bucket ID and the output. For each bucket, I have how much CPU, how much weight, but that's not very friendly. I want graphics. So what I want is going to add this graphic. So if this is 5 pluses and 5 minuses, and one AS is 5, this is an AS of 2, half on CPU, half on weight. So I'm just going to use RPad to create SQL ASCII art. So I'm going to RPad pluses for the CPU. I have CPU AS, and then I have the width of the bar, and same thing, I concatenate that with the weights. But I'm missing something, I'm missing the yardstick. So if I see a spike, I don't know if that spike is big or little, but I really use a yardstick, and the yardstick is the number of CPUs. So I'm going to insert in the middle of that bar the number of CPUs. So I'm going to concatenate CPU, weight, and then I'm going to add the bar. So how do I do that? The way I do it in SQL is I draw the whole bar twice. The first time I draw the whole bar and slice off up to the CPU count. I concatenate the CPU count, and then I draw the whole bar again and slice off the bottom. So I'm going to go a little faster because this is a bit tedious. That's what it looks like in SQL. And the idea here is on the bottom in blue is that raw output, and then on top I mold it with graphics. I add the CPU weight bar. And this is what it looks like. So this is cool. Now I have my graphics, but I don't know what I'm waiting on. So I need to add in what was the top weights in each of those buckets. So in the previous raw data, I just did a count star on the CPU and weight event. What I actually need to do is actually look at each of the weight events. So here's basically the same raw query. So I have my bucket ID, but instead of just doing a count, I have my actual event and event count. And the output looks like this: bucket ID, event, and how many times I've waited for the event. And somehow I need to pick out the top 2 events. How do I do that? I can do that with analytics. So here I'm going to say row number over partition by ID and event count. And I'm going to pick out the top 2. It's going to rank them all, but I'm going to pick out the top 2. I'm going to add one of the columns as percent. That weight event contributed to how much percent of the total time in that bucket. So here's the output, and then this output for each line, I just have to pop off the top 2. So here's what it looks like in the query. I select out just the top rank 1 in its percent, and top rank 2 in its percent. And then for each bucket, I just get the top 2. Bucket ID, first event percentage, second event percentage. And then we add the graphics. So this is what it finally looks like. I have my time bucket, I have my first weight event, how much does it contribute to the total, second weight event, the graph. I added one thing in the graph that I hadn't shown yet, that's the zeros is I/O. So I have CPU, I/O, and weight. So this is cool. This is what's happening right now in BDAL active session history, which is in memory. What about what happened yesterday or last week? We need to use a different table. That's the DBA HIST active session history. So DBA HIST active session history is a little bit different. It only has 1 in 10 samples. Oracle throws away 9 out of 10 of the samples. So my query is going to be different. And this also has DB ID. So I don't know how many of you guys have started working with the AWR centralized repository, what do they call it, AWR warehouse. Something I've been doing for a long time is having all my different databases stored in one repository so I can query them all. Well, this view has the DB ID, so I have this repository. I can go look at this by database. One thing I wanted to mark at the end of this is really awesome data. You really should keep it for a long time. By default, the AWR repository is only a week. But you can go in and modify it with DBMS workload repository modified snapshot settings. These are in minutes, and the first value is the time that it keeps. So I upped it to 1 week, but that's not long enough. I would keep a year easily. If this is an important database, that's very rich data. So I'm not going to go into these queries, but I'll show you what's in the repository. So those load charts, I do them historically. So the first one If we want to do it live, it's going to run fast. It goes off eval active session history. That's the one we see. Second bullet point in gray is the query. It uses both active session history and the historic DBA hist. It's going to be slower. And the last one only uses the history, but I have several options. I can go look for example, a specific database ID in history. That's the first one on the bottom bullet point. The second one, I can actually go look for a particular program in the history. Or the last one, I can look for a particular SQL ID. What was the load of the SQL over time? Is it getting worse? Getting better? How's it changing? So the first one's going to be fast as in memory. As we start accessing the history, then you get slower. So that was the first part, load charts. The second part, which I think is really cool too, is SQL elapsed time. How long did it take us to execute our SQL statements? And we can get this from active session history. Version 11, Oracle added something really cool from my point of view as a geek. They added two fields, SQL exec ID and SQL exec start. Why are these cool? It's because if I run a query, a really fast query once every second, and say it takes a second each time. So ASH is going to capture each time, but each time it executes, it's actually a different execution. That's going to look exactly the same as one query that took 5 seconds. How do I know the difference? Well, I know the difference with these fields. Every time I execute the same query, it's going to get a different ID. And it's also going to tell me when it started. With that information, I can see how long the query took. So in Ashmaster, there's 3 queries for this. The first one is the simplest. It has for each SQL ID, it has how many executions did I find in ASH. It has the maximum execution time in seconds, average execution time, and minimum execution time. And when I first put this together, my question always came to mind is, like, for this maximum time, is this an outlier, or is the execution times, are they distributed over the range? So then I changed it to the second bullet point, where the last 5 columns are buckets. So if I take the total execution time between the fastest and the slowest and slice it into 5 different equivalent buckets, how many execution times do I get in each bucket? And this will tell me if there's an even distribution or if there's an outlier or a couple of outliers. And then when there are outliers, then the final question came up to my mind is, who was the outlier? How can I analyze the outlier? That's what this last query is. The last query has a column in the middle right. It says longest SQL ID. This is the ID of the longest running execution. With that, I can go find out why did that outlier, why was he slow? So here's the output from the first query, SQL ID executions max average min. I think we're running out of time. So in these slides, I want to go over, I explain a little bit how I get the data I want. I'll just skip over this because we're probably running out of time. So this is that third example, the longest exec ID. So if I find the longest exec ID for something that has an outlier, so that first line has an outlier. In the first bucket, the fast bucket, almost all the executions. There's one execution in the longest bucket. So one guy, there's an outlier. What happened in that case? I take the longest SQL exec ID, and I can go back in active session history and get what that query was doing. What was the profile of that query? And then I can study it more and see how that differed from the fast execution. So the third area, so we've talked about load graphs, we've talked about SQL execution time. This is for an analysis particular weight events. So let me go over 2 buffer busy waits and enqueues. So we already looked at the buffer busy waits. If you say AWR, you see buffer busy wait as a problem, you basically can't go any farther. But if you go into active session history, you can get all the data you want. So there's a query called ASH_BB_wait that will get all the information you need. The output looks like this. It tells you the object we're waiting on, the object type, in this case is an index, the file and block number, and the SQL and block type. With this output, that's enough to solve it for most cases. As we saw, if it's an index, we can do a hash index. If it's a table, we can put it into ASSM or add free lists. This is the query. Does this end at 3:15? What time does this end? Okay, so I'm going to go a little faster. Okay, second wait event, enqueue. So this is typically, normally, when 2 users are trying to modify the same row, and one guy hasn't committed and the other guy's trying to modify it, so he has to wait. It might look like this in AWR. I see most of my waits on these blocks. How do I analyze it? I want to know who's waiting, who's blocking, what's the SQL, what's the row. not in AWR, but most of it's in ASH. All these different things we're looking for in ASH. We just need a query to pull it out. Here's a very simple example of a query. It's called ASH enqueue. It pulls out all the information I want. It's going to pull out who's the waiter, who's the blocker, what objects are they involved in. Now, this is interesting. I don't know how many of you guys run into this, but if the mode, let me go back. So we can make a lockout in a share mode or exclusive mode. In the case of two users trying to modify the same row, it's an exclusive, or the ID is 6 for an exclusive lock. Sometimes we take things out in share mode for different reasons, and the mode's going to be 4. And those can be difficult situations to analyze. So I run this query, and I have the output. This is sort of the profile of different share mode lock contingent problems that can be misleading if you haven't seen them before. So the first case is unique key. What if somebody has inserted a unique key and somebody else tries to insert a unique key? I'm going to get an enqueue lock in shared mode 4. When I run this query, you can see the note, there's no object ID, but I do get the blocking session ID. So that's sort of the footprint of people having locking of a unique key. How about foreign key? How about if somebody put an ID in the parent table and somebody tried to insert that value, the same parent ID in the child table? I'm going to have to wait. What does that look like with the profile? I don't get the blocking SID, but I do get the name of the child table in the output. And that might be a case of where you need an index. In the last case, bitmap. So bitmaps cover ranges of row IDs. So I can change one row, you can change a different row and still lock on a lock. In this case, it's a shared lock. And it'll point us, one thing unique about it is objects can be indexed. We'll know, we see an index, odds are it's a bitmap index, and that's the problem. Okay, so that's the first 3 sections. Fourth section is top procedure, top session, top SQL. I think this is really cool. So when ASH first came out and didn't have this in 10.203, they added it. It's the procedure, package procedure entry point and package procedure execution point. So even if I haven't tagged with module action my PL SQL, I can go in and profile where what procedures and packages are spending the most time. So these IDs, they translate in the all procedure view to the package and procedure, and then we can run a query like this. I think it's super cool. So the count star is how many times did I find this being executed and who was it? So the calling code for the most expensive one is order entry package, procedure browse, and update orders. And if I'm in one package that calls another package, we'll see it. That's what this, in the first line, the pointer. So I came into one package and I called another package. So this is an instant free profiler. I don't even have to tag my code. So we've already seen this, top session. We saw this top SQL. In the last section, we're almost out of time, is I/O. We can do lots of cool things with I/O. So we can sort I/O by SQL, we can sort I/O by objects, sort I/O by table space, sort I/O by the different wait events. The one I like the most is this I/O SQL.sql. So it has, the first column is how much load is this query putting on the database, AAS. What's the query ID? And then for the I/O, where's the I/O coming from? It'll name each object that's used by that query and which object is causing the most I/O. So for this first query, the OY ID, most of the I/O is coming from item order index. And this is really cool. For the second one, most of the I/O is coming from undo. And this can be super misleading. Like if so say we have a nightly batch job that usually finishes before we kick off some queries in the morning. If it doesn't finish and has lots of uncommitted outstanding changes, when I go in and run a query, maybe it's a full table scan in the morning, it's usually really fast, it's going to be super slow when it has to go rebuild up the image with the undo. How do you know that? I've seen this query come across on the help desk a lot. Well, if I run this IO SQL.SQL, I see immediately most of that IO is coming from undo. Somebody didn't commit a lot of outstanding changes. What's that? Sorry, I don't understand the question. Oh, good question. Yeah. So second, there's no SQL ID. It's group by. So the first line is SQL ID. The others all apply to that first SQL ID. And then the last area, and I think I'm out of time, is latency. Some people try to get latency by using time weighted in ASH. If If you don't know how to use it, odds are there's only a few people in the world that know how to do it, although it's not that hard. You're going to get the wrong results. So I don't get latency from ASH. I get it from these different either weight class metrics, event metric, or DBA system event. So I have 3 queries in ASH repository to get it. Latency from weight class metrics will tell me IO average latency. I don't really like that. I like to know which weight events have which latency. So I can go into the event metrics and get the latency by event. This is the last 60 seconds. If I want to see it over time, this is the query. If I want to see it over time, I can look at DBA system event, and I can see when I run the query, it's going to ask you what weight events you want to see, and then it'll give me the average latency for that weight event by hour. Finally, ormon.sh. If I want to see latency, this is like weight IO stat, except for Oracle database. So if I run ormon.sh, for the different weight events, it'll tell me average latency, number of IOPS every 5 seconds. It just keeps putting lines out. So in summary, load on the database is AES, average active sessions. I get that by DB time over elapsed. I can get that from ASH by doing count star of elapsed time. So our basic core query is count star of elapsed time, and then we can give in our grouping criteria, top sessions, SQL, whatever we want to look at. The repository has all these custom queries: SQL, execution and max time, top SQL, top session, IO, and my favorite thing is load charts. And that's it. Thanks for coming, and enjoy the video.
Short and sweet.
Yeah, thanks. 45 minutes, right?
Yeah.
There's a lot of stuff in there, so.
You know, a lot of information.
Yeah, it's a lot of information there.